likening or likening your minds, as I like to use this, to gardens. And I'm saying again, I read this little quote somewhere that whatever you plant in the garden, that's what you're going to reap out of it. And we are going to be planting thoughts about mathematics. And these are thoughts that are simple, that can help you in real life. Help you when you go out into the world, or if you're a housewife, you can use it in the kitchen. Or if you're a farmer or you're a businessman, you can still make use of it. Good. Now, in this lesson, we're continuing with algebra, and we're looking at equations. But these are equations that have more than one variable. And we're solving two equations at the same time. So if we're taking two equations and solving them at the same time, what is the whole concept surrounding those solving at the same time? We call them
Simultaneous equations.
simultaneous equations. So let's put our topic up. So we're taking equations and solving them at the same time or simultaneously. We're finding values that can satisfy the equations to make them balance. Now I'm going to put a pair on the board here. I have our first example. X plus y is equal to 13. And 4x plus y is equal to 31. Now, in solving simultaneous equations, we can adopt two approaches. We can either go the method of substitution, or we can adopt the second approach called elimination. In this lesson, we're going to be using substitution. Now we have two equations here. Equation 1, equation 2. Now we are accustomed to seeing 2x plus 3 is equal to 5. When you look in this equation, you see only one variable. The variable is x, and we see three constants. 2, the coefficient, 3, and 5. So we can take the 2, the 3, and the 5 and group them and find the value of x. So we have 2x is equal to 5 take 3. 2x is equal to 2. X is equal to 2 divided by 2. X is equal to 1. Without a problem, we could have found for x, because this is a simple linear equation. In these up here, we notice two variables, an x and a y. And because we have two variables in those, we cannot proceed in this manner. Now, let us look at equation 1. In both variables, the coefficients are 1. In the second equation, the coefficient of the x is 4 and the coefficient of the y is 1. Now, we want to apply the substitution method here. So we have to understand, what does substitute mean? What does a substitute mean? When you hear the word, what meaning comes to your mind? What thought, what idea comes to your mind? You have to understand that first. I'm a substitute for somebody. What does it mean?
A replacement.
A replacement, or I'm filling in, or I'm taking the place of someone. So we have got to create a condition where Either we're going to replace an x or replace a y. So we're going to take one of the equations and write it in such a way that x has a value or y has a value. Now it's easier to work with equation 1 since the coefficients are 1. So let's write equation 1 here. So we're going to take equation 1, and we need to either make x the subject or y the subject of that equation. We're going to take equation 1 and make, which one do you want us to make the subject, x or y?
Y.
Y. And make y the subject. Now when we say make y the subject, it means that when we're done, we must have y is equal to something over there. Y alone must be on one side. So we write back equation 1. X take y, x plus y is equal to 13. We need to get rid of the x. In getting rid of it means moving it from the left hand to the right hand to join the 13. It's connected here by addition. So we go across and subtract. Therefore, y is equal to 13 take x. Now we know something about y. We know that y is equal to 13 take x. Next step, we're going to use equation 2 and substitute y equals 13 take x. Now this is when the substitution comes. Equation 2 says 4x plus y equals 31. Instead of writing back y has a value now. This is y's value, 13 take x. So we're going to substitute the value of y for y. So we have 4x plus 13 take x, and out comes 31. Let's group the x's. 4x take an x plus 13 is equal to 31. 4x take x would be 3 x's. And then we're going to group 13 with the 31. We're going to have 31 take 13. 3 x's. If we take 13 out of 31, what are we left with? Pardon? 18. Very good. 18. Therefore, x is equal to 18 divided by 3. X is equal to 6. 3 1s, 3 6s are 18. So we substituted after we made some value of y in this form in terms of x. We substituted that value into this equation. And after we replace it, what do you notice here? How many variables are in here? How many types? One type. And because we only have one type, which is just the x, that facilitates the solving of the equation. So here we can go ahead and find the value of x. Now that we have x, you notice we have an x and a y. Now that we have x, we can use x, put it back into any one of these two to find for y. So we're going to substitute x equals 6 in equation 1. Equation 1 says x plus y is equal to 13. X is 6 plus y equals 13. Y is equal to 13 take 6. Y is equal to 7. So our solution, x equals 6, y equals 7. Now, we're not sure if we're correct. Let's make sure we're absolute. Let's go back. So x is 6, We add that to 7, and will we get 13?
Yes.
Yes. Now let's check the second one. It's 4 by 6, and then we're going to add 7 to get 31. 6 4s are 24, plus 7. Will it give us 31?
Yes.
So we're correct. So we have two values that satisfy both equations. So we say we have solved them at the same time or simultaneously. Take this example. Okay? Now we have a second pair. 5x plus 2y equals 29. X take y equals -4. Now this is going to be your challenge. But before you get into it, let's start the initial phase. Now the first thing you should do is to name your equations. What do we call this one?
Equation 1.
Equation
2.
2. Then you ask yourself, should I use equation 1 or equation 2, and which variable should I choose? Now when you look at equation 1 and equation 2, which one do you think is more suitable?
Equation 2.
Equation 2. So you write your statement. We're going to take equation, I put EQ shortened, equation 2, and make, now you have got to decide that if you take equation 2, x take y equals -4, then you look again. Should I use x as a subject or should I use y? Then you look again. X is positive, y is negative. Should I use x or should I use y? You ask yourself these questions. If I use x, then when I take y across, y becomes? So is it easier, simpler for you to use x as the subject or y as the subject? X as the subject. Because in using x, you get rid of the negative in the y. So, and make x the subject. So, go ahead, copy your equation, copy the statement, and you make x the subject. Ready to go. So, if we make x the subject, what would x be equal to? Bria?
-4 plus y, or y -4.
X is equal to -4 added to y, or we can say x is
Y.
equal to
Y minus
y
4.
take 4. And this one here, this answer here, is one that your mind is much more familiar with than -4 added to y. Okay? Good. Now that we know something about x, what do we proceed? Next stage, Matthew.
We substitute.
What do we substitute?
In the equation, we substitute for x. Which is y
Which
minus
one
4.
of the equations do we substitute into?
The first equation.
First equation. So did you make your statement? So we're going to substitute x equals y take 4 in equation 1. We state equation 1. 5x plus 2y equals 29. Instead of x, we're going to put it substitute. So we have 5 goes into or is multiplied by y take 4 plus 2y equals 29. So as soon as we move from this state and we would have substituted, automatically you only see one variable. So we can have a solution. When you multiply it here, Renita, what will we get?
5y.
5y
Take 20.
take 20
Plus 2y. Equal 29.
Equals 29. So we've got to do some grouping here of like terms. So we're going to group the 5 and the 2 and take the 20 across with the 29. So we have 5y plus 2y is equal to 29. Should we add or subtract the 20?
Add.
We're going to add the 20. 7y is equal to 49. Y is equal to 49 divided by 7. 7 1, 7 7. Y is equal to 7. Now we know that y is 7. We resubstitute y into any one of the two to find for x. Which one of them did you choose, Lisa? Equation 1 or 2? Equation 1. So we use equation 1 and substitute y equals 7. 5x plus 2y equals 29. Y is 7, so we have 5x plus 2 by 7 equals 29. 5x plus 14 equals 29. 5x is equal to 29. Take 14. 5x is equal to, what do I have there? 29 take 14. 15. X is equal to 15 divided by 5. 5 1s, 5 3s. X is equal to 3. Solution. X is equal to 3. Y is equal to 7. And then if you want to, you can take them back up there and check to see if they balance. For example, x we know is 3. Take 7 has got to be -4. Balances. Good? Now we have already been given these. Equations are straightforward. We've been given them. Now across there, we have a case where we have a worded form. Somebody has a situation there with rackets and bats. This would be example 3. So let's read the statement and read it so we can really understand what it's saying. A racket costs $12 more than a bat. $12 more. If we paid $10 for a bat, the racket would be $10 added to the 12. It's $12 more. The cost of 2 rackets and 3 bats is $619. So we have 2 situations there. One, where we know that 1 racket costs $12 more than the cost of a bat. And the second situation, 2 rackets and 3 bats. When we find the sum of them, we come up with $619. Using X to represent the cost in dollars of a bat, 1. Write an algebraic expression for the cost of a racket. Now we're going to use X to represent the cost of a bat. Okay? Cost of a bat, that's what we're going to use X to represent. Now let's go back here again. A racket costs $12 more than a bat. So where we see bat, we can put in an X. So the first question asks us, write an algebraic expression. Not an equation, an expression. We don't want an equal sign in it. For the cost of a racket. We're going to use X to represent what a bat is. What would that expression be? Who would like to tell me? What do you think it will be? Matt, you want to try?
X plus $12.
X plus 12. Now we're going to put in our dollar sign at the end because it's a little confusing to work with it. What do you think, Renita? What do you think the expression is going to be?
X plus 2.
You agree with him? You agree with him, Lisa?
Yes.
What about you, Renicia?
Yes.
Yes, you agree with him too. And I know Ria is going to say the same thing. Good. So the cost of a racket is $12 more than it. So if X is the bat, we add the $12 and this whole sum will give us the cost of the racket. So when they ask us for an expression, here we have our expression in terms of X. We're finished there. We move on to our second piece. Write an algebraic equation to represent the total cost of 2 rackets and 3 bats. The total cost of 2 rackets and 3 bats. Now, they gave us X here to use as bats. For rackets, we're going to use Y. So I want you to take the variables X and Y and come up with an equation for what is going on here with the 619. Write down the equation in your book. Good. Now let's examine it. They say use X for a bat. How many bats were bought?
3.
3 bats. So we have 3 X's. And we said let us use Y for the rackets. How many rackets?
2.
2 rackets. And when we sum the cost of the 2, we're going to have 619. So here we have our expression. And here we have our equation. Can we proceed? Good. The third part. It says, solve the equation to find the cost of a racket. Now we know that X is for bat and Y is for racket. We also know that a racket is X plus 12. We also know what that is. Okay? Now, when we look at this here, we can also say that Y, the racket, is equal to X plus 12. So we also know a value for Y. So we are going to substitute. So we're going to come here, write back our equation, 3x plus 2y equals to 619. 3x plus 2, what is y? X plus 12 equals 619. 3x plus, this 2 is distributed over the x and the 12, not the x alone. 2 multiplied by x, 2x. 2 multiplied by 12, we're multiplying, would give us 24 equals 619. Let's group. 2x plus 3x would give us
5x.
5x's. Would be 619, take 24. When we take 24 from 619, how much are we left with? 4 from 9 would be 5. Yes, Lisa? 2 from 10 would leave us with 8. And we have 5 remaining. Therefore, x is equal to 585 divided by 5. X is equal to 5 ones, 5 ones, 5 ones, 5, and 3. 5 into 35? 5, 7, 35. So we have x is equal to $117. So, okay. This shouldn't be a 2 from 595, right? Should be a 9, not a 5. Good. Good. Now when we take, so we say 5x is equal to 619, take 24. And when we take 24 from 619, we're left with 595. Now x is equal to 595 divided by 5. And x is equal to 5 ones, 5 ones, 5, 5 ones, 5, and 4, 5 nines, 45. $119. Now, what did we say x represents?
The cost of the bat.
The cost of a bat. So we say the bat equals x equals 119. What did they ask us to find the cost of a?
Racket.
Do we stop here? No. So we're going to substitute x equals 119 in either we go here or we go here, either one. So we know that the racket y is equal to x plus 12. Y is equal to 119 plus 12, and y is equal to $131. Now let us add up the bats and the racket value and see if we'll end up back with our 619. So we bought 3 bats and 2 rackets. So we have 3 by 119 plus 2 by 131. Let us see if we get 619. When 119 is multiplied by 3, what do we get? 357. And when we multiply 131 by 2, we have 262. When we add 262 to 357, 2 and 7, 9, 5 and 6, 11. The 1 and 2, 3 and 3 will give us 6. So we know our value satisfies that equation. So you see how we can take worded statements, make our equations or expressions, and solve to find what we need. So here we have taken equations containing 2 variables, and we have solved them simultaneously or together to find values that satisfy both equations to make them balance. Okay? We can either be given our equations, or we can either be given worded form, which we read, comprehend, and then we extract. Extract, we make expression, and then we make an equation. First, you have got to read and comprehend, understand what is going on. You make your statements, and then you solve. And this method of solving the equations at the same time is called the method of substitution. Now let us recap quickly what we were doing. Look here, look here. Lesson 23, Algebra, Simultaneous Equations. In this lesson, we will solve simultaneous equations using the method of substitution. Here are some key points. Simultaneous events are events that occur at the same time. When two or more equations are satisfied by the same values of the unknowns, they are called simultaneous equations. Simultaneous equations can be used to solve many real-life problems. Let us solve simultaneous equations by method of substitution. Example 1. Solve the equation x plus 2y equals 4 and 2x plus 3y equals 7. Solution, step 1. Rewrite the equations as x plus 2y equals 4, equation 1. 2x plus 3y equals 7, equation 2. Step 2. Since the coefficient of one of the variables in the given equations is 1, express one unknown in terms of the other. From equation 1, x plus 2y equals 4. X is equal to 4, take 2y, equation 3. Step 3, substitute. 4, take 2y for x in equation 2. Equation 2, 2x plus 3y equals 7. Then 2 into 4, take 2y plus 3y equals 7. Step 4, clear the brackets and simplify. From 2 into 4, take 2y plus 3y equals 7. We get 8, take 4y plus 3y equals 7. 8, take y equals 7. Let us solve for y. Negative y equals 7, take 8. Then negative y equals negative 1. Multiply both sides of the equation by negative 1. Negative y by negative 1 equals negative 1 by negative 1. Therefore, y equals 1. Step 5, we know that y equals 1. Let us substitute the value 1 for y in equation 3. X equals 4, take 2y. To find x. X equals 4, take 2 by 1. X equals 4, take 2, and that's equal to 2. Hence, x equals 2, y equals 1. It is always important to check your solution. In equation 1, x plus 2y equals 2, plus 2 by 1 equals 2 plus 2 equals 4. Left hand side equals right hand side. In equation 2, 2x plus 3y equals 2 by 2 plus 3 by 1 equals 4 plus 3 equals 7. Left hand side equals right hand side. Example 2. The sum of the digits of a two-digit number is 12. The number is 13 times the 10th digit. Find the number. Solution. Let t equal the 10th digit. S equal the 1st digit. In any two-digit number, we will have a numeral in the ones column and another in the tens column, giving rise to the number represented by 10t plus s. Since the sum of the digits is 12, then t plus s equals 12, equation 1, and 10t plus s equals 13t, equation 2. T plus s equals 12, equation 1, 10t plus s equals 13t, equation 2, S is equal to 12 take t, equation 3, from equation 1. Substituting S equals 12 take t in equation 2 gives 10t plus 12 take t equals 13t. 9t plus 12 equals 13t. 9t take 13t's equals negative 12. Negative 4t equals negative 12. Therefore, t is equal to 3. Substituting 3 for the value of t in equation 3 gives S equals 12 take t. S equals 12 take 3. S equals 9. Hence, the number is 3 tens and 9 ones. Let us check our answer. T plus S equals 12, equation 1. 10 t's plus S equals 13 t's, equation 2. T equals 3 and S equals 9. Substituting in equation 1, 3 plus 9 equals 12. Substituting in equation 2, 10 by 3 plus 9 equals 13 by 3. 39 is equal to 39. The sum of digits equals 3 plus 9 equals 12. Number is 13 times 10 digit, which is 3, equals 13 by 3 equals 39. Summary: simultaneous equations can be solved by the method of substitution. An equation remains the same if every term is multiplied or divided by the same quantity. The solution of equations must always be checked. Substitute the solutions in the original equations. Left-hand side equals right-hand side. Problems for today is taken from Mathematics for Secondary Schools in Guyana, Book 3, on page 68, exercise 5E, questions 2 and 12. Page 71, exercise 5F, questions 8. Solution for the problems given in the last lesson. Page 65, exercise 5D. Number 2, 4 to the x power equals 16. 2 to the 2x equals 2 to the 4th. 2x equals 4. Therefore, x is equal to 2. Question 6, 9 to the x equals 1/3. 3 to the 2x equals 3 to the minus 1. 2x equals negative 1. Therefore, x is equal to negative 1/2. Question 10, 6 to the 3a equals 1/36. 6 to the 3a equals 6 to the negative 2. 3a equals negative 2. Therefore, a is equal to negative 2/3. Question 12, x raised to the 1/3 equals 4. X to the 1/3 equals 64 to the 1/3. X to the 1/3 equals 64 to the 1/3. X is equal to 64.